All right. So the last section of this lecture is to talk about securing infrastructure as a service solutions and then summarize. The problem with infrastructure as a service solutions from our perspective, from the idea of teaching security primitives, is that it's such a highly variable approach to doing cloud-based computing that what you are actually building matters a lot in terms of what you need to do to secure it. And I can only give you some high level overviews of things that you may want to consider in an infrastructure as a service scenario. The first of those is storage. Whenever you're deallocating storage on a shared environment, there's a possibility that it just gets immediately reallocated to other users, potentially exposing your data. This is not dissimilar from simply taking the hard drives from machines that you had used internally and throwing them in the dumpster. Whoever ends up getting access to that dumpster could take those hard drives and just plug them into new machines and see whatever data might exist on those hard drives. And there have actually been quite a few examples of people who've bought computers at rebate sales and like deallocation sales and found like very critical, healthcare patient data, national security type stuff just exposed on a hard drive that hasn't been properly erased. So whenever you're talking about shared storage and you deallocate something, prior to deallocation, you should wipe it. Use some way of cleaning out that data before you deallocate it from your system. It could just be immediately given to somebody else. Same sort of thing happens with network resources, right? Rather than just storage. This is like data in transit. The typical practice is for people to just prevent people from sniffing other traffic. And that means like Amazon would say, well, you're not allowed to look at any of this traffic. In practice, that's problematic because you're leaving the security primitive up to the infrastructure as a service provider rather than yourself. So the safest bet really is encrypt everything that you have going from your organization to the virtual machine that's being managed by Amazon or whoever your cloud provider is all the time. As long as it's all encrypted, then even if it is made available, somebody could sniff it, you're not going to have the same kind of security exposure that you would as if you were just relying on the infrastructure service provider to make sure that somebody else can't see your traffic. And then finally, host access. Of course, any infrastructure as a service platform is still going to have these traditional login authentication issues. And in this particular case, you may actually be even more exposed because instead of having a system at your own facility that you have to secure, this is available over the internet to anywhere in the world. And anyone who can actually access the system with the username and password would get complete access, right? So always require two-factor authentication. Never, ever allow your network administrators or infrastructure service engineers to use a shared account, right? They always have to have their own account that is then approved, probably through some sort of a federated identity system like we talked about before, to have access to the system. Make sure that you not only have policies enforcing principle of least privilege, but that you review them on a regular basis to make sure that this principle still applies. It's very common to see people who are promoted at an organization to simply be given more responsibilities and access to more resources and never have anything taken away from them. This can happen for legitimate reasons, right? You still want the institutional knowledge of, somebody who's done your old job to be able to help out in that area where necessary. But it is a security issue to have one individual with access to so much of your infrastructure and so much of your information. So it's worth auditing to make sure that least privilege still applies. And then finally, use OAuth rather than passwords to give applications access to API interfaces. OAuth is much more secure than passwords because as authentication tokens, they can be remembered by the computer and they can be much longer and harder to guess. So there's no easy brute force way of violating an OAuth token that you would have with a brute force way of guessing a password. Much, much more secure. Similarly, use federated identity management wherever possible so that you really only have to manage that one set of accounts at your own organization. And this kind of ties into this notion of shared accounts and two-factor authentication and that sort of stuff. It's much easier to avoid those if you're using federated identity management for all of the stuff you really care about. All right, finally, here is the security architecture that is like generically recommended for infrastructure as a service companies. You can kind of think of this as like a map of a provider network like Google, right? They have this boundary enclave, right? And then inside of that, there are proxies for both file data and then generic web traffic. And then inside of that, there's another enclave for all of the servers that exist to actually serve content, either serving file content or web content. They've taken pains to separate things as much as possible on the inside of this, but that's not necessarily a guarantee. And all of the mechanisms that we just talked about here are an attempt to help make that even more secure for your own organization. But outside of these two slides, outside of these two high-level overviews of infrastructure as a service, it's very hard to give specific recommendations about security because it really is going to depend on what you are doing, what kinds of sensitive information you have access to, and what your organization is intended to do. All right, so that's everything we wanted to talk about cloud computing. I think the main thing to talk about in terms of what's confusing for students and what may be problematic when you get to something like the final exam is federated identity management. Knowing the difference between SAML and OAuth and also OIDC does make a huge difference when you get to the final exam, because I'm going to have to ask questions about some of these technologies in a little bit of detail. I probably will not ask questions about the specifics of something like this OAuth authorization process that we were talking about in the last part of this lecture, because I don't want you to have to memorize something like this. That's not the goal. But you do need to know the difference between like what is SAML and why would you want to use OAuth as opposed to SAML, or SAML as opposed to OAuth, and then how does OIDC fit in the picture of both of those for questions on the final exam. That's something that I will ask about. High-level differences between these three protocols and how they relate to the general concept of federated identity management. Okay, that's everything for this lecture. Hopefully this has been successful for this first week, and we will see how things go. If we have to change things, I will have no problem pulling the plug and doing an entirely different approach. I want to be as flexible as possible during our current online teaching environment. So please give me as much feedback as you can about whether or not this worked, what didn't work, that sort of thing, and I'll try and adjust as we progress through the rest of the semester. Thanks.